In today's video, we are going to discuss about the problem n queens problem. So n queens problem is a classic chessboard puzzle. So we can place n queens in an n by n chessboard. So if it is a 4 4 by 4 chessboard, we can place n queen without attacking each other. So we all know that how a queen moves. A queen can move in a straight line as well as in a diagonal. So no other queen should be placed in this position when in the same row, same column and in the same diagonal. So yes, this is how a chessboard is represented. So in a chessboard there are consider this chessboard. This is an 8 by 8 chessboard and there are so a queen can move n by cn to the power of n by n times. So this is the maximum number of time a queen can move. And this is the problem. No queen, so this is how a queen can move. A queen can move in one in a straight line, that is row, column and in diagonal. So no other queen should be placed in these directions. No two queens can share the same row, they cannot share the same column, nor can share the same diagonal. So how do we solve this? I am going to solve this using backtracking. So we place the queens one by one, checking if we have placed in a correct position. If not, we will backtrack. That is, we will go a step before and try a different position. This is how we are going to solve the n queens problem. So let us start working on our problem. So let us get on some hands-on and do some coding.
So let us check how we can place the 4 queens inside this 4 by 4 chessboard. So if we place the first queen in the first row, second in the second row in a diagonal way, it is not correct, right? So we have to move this position. By the way, if you're new to my channel, please do consider subscribing to my channel and click on the bell notification item so that you will receive all of my future videos. Do like, comment and share this video with all your friends and family and all the coding enthusiasts. We will come up with another exciting videos every week. Now let us try to keep the first queen in the second column of the first row. Now let us check if where we can keep our second queen. So second queen can be kept only in the fourth column of the second row, so that no other collision will happen. Third queen, the only safe position for the third queen is then in the first column of the third row. Now the only safe position of the fourth queen is in the fourth row. So the positions are 2, 4, 3, 2, 4, 1 and 3. So this is according to the column number. Now let us consider there is one more correct position. It is exactly the mirror image of this. So this will be, instead of 2, it will be the next column, that is 3 for the first queen. Second queen, instead of the fourth position, can be placed in the first column of the second row. And the third queen can be kept in the fourth column of the third row instead of the first column. And the fourth queen can be placed in the third in the second column of the fourth row. So it will be like 3, 1, 4 and 2. Exactly the reverse of the first solution. So this is how we are going to solve this problem. So our code begins by initializing the size of the chessboard as 8 by 8. So now I am giving the size of my chessboard as 8 and I am creating a two-dimensional integer array board to represent the chessboard. Each cell in the board will be set to 0 initially, indicating an empty cell. Now let us start writing the printBoard function. PrintBoard function is responsible for displaying the current state of a chessboard. It loops through each of the board array and prints its content, either 0 or 1, representing an empty or whether it is occupied by a queen. So since we have written it as a print line, that is why it is not printing as a chessboard column. Now let us again run this. Now our chessboard is ready. Our printBoard function is ready. Now let us start writing another method, isSafe, which returns a boolean. This function checks whether it is safe to place a queen at a given position in the board with the corresponding row and column. So 3 conditions are checked here. Horizontal attack. If the queen is in the same row to the left side. Upper diagonal attack. It checks whether the upper diagonal, left diagonal, to ensure a queen is already there. So that condition is checked in this part of the code. Lower diagonal attack. It checks the lower diagonal to ensure no queen is already there. If all the 3 conditions are met, no queen threats the current cell and the function returns a true, indicating it is safe to place a queen in that location. Now let us start writing the solve queens function. So this is the heart of our algorithm. It is a recursive function. It attempts to place the queen column by column. It starts with the leftmost column, that is the call equal to 0, and goes to the right. For each column it iterates through the rows and checks if it is safe to place the queen there. If it is safe, it places the queen and recurs to the next column. If the placing the queen doesn't lead to a solution, it backtracks by setting that cell back to 0. This recursive process continues until a valid solution is found or all the possibilities are exhausted. So that is what is done in this method. Now let us go to the main method. So this is actually the entry program of our application. It calls the solve queens problem solve queens function to attempt to solve the 8 queens problem. If a solution is found, it prints the solution by calling the printBoard method. If no solution exists, it prints a method indicating that no solution exists. Our solution is working fine and we are able to get the result. So let us make the chessboard to 4 and try again. So we will get the solution in 4 by 4 matrix, the same which we had discussed before. So this is how we can solve an n queens problem. So I hope you all liked it.